Today's edition of What Happens When Genetics Gets Weird, we start out with polygenic inheritance. And as the name sounds, poly means many, and genic, we're talking about genes. So this tells you that we're talking about many different genes that affect one thing. Remember back when we were talking about the beginning of genetics and traits and how they are passed from parent to offspring, I said our eye color is very complicated and it isn't just a 4-square Punnett square that we can figure out. That's because it is polygenic and it is a combination of many genes. Also the same with the things that list here, such as size, weight, shape, height, color, metabolic rate, etc. So a trait affected by the number of genes or polygenes does not show a clear difference between groups or individuals. Instead, it shows as a graduation of small differences. So this is how you can have a completely different eye color than anybody else in your family. And it mentions that many normal human traits are polygenic because we are all different. Of what happens when genetics gets weird, we get into sex-linked determination. So remember when we talked about somatic cells, we said there are 23 pairs of somatic or autosomal chromosomes, and then we have the last set that are the sex chromosomes. So you either got the XX, which means that you are a female, or you have the XY, which means you are male. To give us our complete total of 46 chromosomes, 22 pairs that are autosomes, and 1 pair that are the sex chromosomes. There are some sex-linked genes that will occur more common in males. Why? Because they have the Y. So if it is linked on the X, it is going to be shown in the male. Okay, one of these examples is with color blindness. So you can have a bunch of different possibilities. You can have both big letter C's, which would mean that will be a female because she's XX, and she has normal vision because she has the 2 big letters. Then we have a big letter C and a little letter c. She's still a female because she's XX, but notice she is a carrier, meaning that she isn't colorblind, but she could pass that trait on. And then the last option for a female is if the female has both little letter C's. If this happens, which is incredibly rare, that female would be colorblind. It is way more common that you would have a colorblind male because he has only 1 X chromosome. So the XY that has the capital letter C, that is going to be a normal visioned male. As where if and only if that male inherited the little letter C from his mom or his dad, then that means that he is going to be colorblind. Works the exact same way with something that is called hemophilia, which means that they are free bleeders and they do not clot like other human beings do. You would follow the exact same way with the normal females, the carrier females, and then the hemophiliac females, which is also very rare, and then the normal versus the hemophiliac male. And the reason why you never see a carrier male is because whatever letter it has on that X is going problems. We also have to know whether or not the parents were hemophiliacs. So that's why you have information about the grandparents. So here we see a normal woman who would be XX, whose father had hemophilia, who would have been XY, married a normal man who would also be XY. What are the chances that they would have hemophilia in their family? So the woman's father would have been big X, little h, because he had hemophilia. Since he had that recessive trait, it showed. The genotype of the woman she would be a carrier because she got that carrier gene from her dad. So she would have the big letter H on one of her X's and the little letter H on the other X. The man says he is normal. So his one X chromosome has a capital letter along with his Y. So then you set up the woman's genetics on one side, the man's genetics on the other side, and then you cross them out. As expected, you would have a 50-50 shot of having a male or a female. So for your genotypes, you just carry over those letters. You have 1/4 of a shot of having X with two big H's. You have 1/4 of a shot of an X with a big H and an X with a little h, which would be what? Heterozygous. You have 1/4 shot of having an X with a big H and a Y, and then 1/4 possibility of having the X with the little h with the Y. So 50-50 shot of male or female. So then we have to assess, of those females, what would that mean? So we would have 2/4 would be normal females. However, 1/4 of them would have been a carrier because it would have carried on that little H. Then we look at the males. 1 out of those 4 males has the big letter H, which is the non-hemophiliac or the normal trait. The other one is the 25% possibility that those two people would produce a hemophiliac male child.